One of the most useful strategies for solving problems is called abstraction. Abstraction simply means that we're going to hide the details. In order to implement abstraction, we can use something that is called a function. A function is just a name for a sequence or a block of actions. And typically those actions are grouped because they are going to be used over and over again. If we wanted to draw a picture of a function, we could simply think about the function as being a box. Inside the box are the details of the function. The way we think about the function is simply to provide the function a name. In order to use the function, the idea is that we only have to supply the function with those things that it might need to do its work. And so if we can identify what the needs of the function are, the details of the function are handled inside, then all we have to do is supply the name and the information that is needed, and the function can do its work. Functions also have the ability to produce output. That is, they have the ability to return something when they're done with their work. And so it could very well be also that there is some sort of an out, some sort of a value that gets produced, some sort of an outcome that occurs as this function does its work. These mechanisms of communication, such as the needs of the function or the output of the function, are what gives the function its generality. In other words, the same function, the same general instructions on the inside of the function can produce different behavior because we provide different needs, different information, and therefore the function produces different values. This is probably best seen by doing a specific example. So let's say that we wanted to create a function that could perform a very simple computational task. And let's just consider a rectangle. A rectangle is going to have a height and a width. So any rectangle in general will have a height and a width. And what we're going to be interested in is to figure out if there's a way that we can generally compute the length of this diagonal that occurs from one corner to the opposite corner. So if we think about this as a function, the job of our function then is to compute the length of that diagonal. So we could think about the name of the function as simply being something like compute diagonal. Now, in terms of this function, in terms of the details that this function is going to have to carry out, what it's going to need to do its work for whatever rectangle we provide, we're going to have to supply both the height and the width. So this function needs the height and the width to do its work, but the height and the width are going to be different depending upon the rectangle that I want to be looking to compute the diagonal for. But of course the output is going to always be that particular rectangle's diagonal length. And so what we're trying to do here is to create a general function that can take some height and some width, that is, for some rectangle, and produce the diagonal length that corresponds to that particular rectangle. Now, in Python, the way that we create functions is to write what are called function definitions. And what I'm going to do is make use of the editor, and I'm going to write this function and the other parts of this program as a Python edit session. And so the first thing that we're going to need to do here is define our function. And so if we think about the picture that we produced, the name of that function was compute diagonal. And so when we define a function, the first thing we do is we use the keyword def. And then that's followed by the name that we want to assign to this function. So in this case, we're going to call it compute diagonal. Now, the name of the function can be anything we want, but it would make sense for us to provide a name that makes sense in terms of what this function is going to do. The next thing that comes then is a list of what are called the parameters. The parameters of the function are those things that the function needs to do its work. And we said that this function is going to need some height for the rectangle, and it's going to need some width for the rectangle that we're interested in producing the diagonal. So this function has two parameters, and so our parameter list, the parentheses, are the markers for this list. This parameter list has two items, and these names then will be the names of the variables that will receive the values when we actually use this function. And the final thing that occurs on this line is a colon. And in Python, the colon typically means that we're about to now define a block or a sequence of code that's going to be part of this definition. So when I hit return, one of the nice things about the idle editor is that it indents over, and it says we're now ready to start writing a block of statements that will be those things required to compute the diagonal, given that we have some height and some width that has been provided to us. So in order to compute the diagonal, if we go back over here to our picture, the height and the width of this rectangle are the information that we're going to have available. In order to compute the diagonal, well, if we think about this as being a right triangle, then this is the very common relationship that the squares of each side, if we sum those together, that's going to be equal to the square of the hypotenuse. And so if we think about these names, h, w, and d, that relationship is going to be written as d squared equals h squared plus w squared. But if we just want to solve that for d, then we're just going to have to take the square root of h squared plus w squared. So the details of what our function has to perform are embodied in this equation, that the length of the diagonal is equal to the square root of the square of the height plus the square of the width. So now we understand the details of what goes on in this box, and coming back over to our function definition then, those details are exactly what we have to now implement inside. And so the first thing we might want to do is to say, well, we know that we have to square the height and we have to square the width and we have to add those together. So let's create a storage location. Let's create a variable. Let's just call it sum of squares, and that's going to be the sum of the squares of the height and the width. Now remember that the parameters are the names of the variables that are going to receive those values, and so inside the function, sum height, sum h, is the actual name of the height for whatever rectangle it is that we're computing the diagonal for. And so the sum of the squares is the height squared added to, and then again, using the same logic, the width of that rectangle squared. So the sum of squares will be a reference to the value that is produced by squaring the height and squaring the width for some rectangle. The next statement then, of course, is going to have to perform the square root. But the problem here is that we don't have access to the square root yet because we haven't imported our math module. So remember that if we put our import statement in place, import math, now we can come down and use the math module. And so let's say the diagonal will be a reference to, and then we can call the square root function, and it's going to be the square root of the sum of squares that we computed earlier. Now we've got the diagonal as a reference to the value that we want to provide as the result of this function. Remember that aside from having needs, functions can also return values. And so we use a return statement, and the syntax is simply return and then whatever expression you would like to evaluate. In this case, we simply want to evaluate the variable diagonal. So now we have our function. We've named the function. We've given the list of the things the function needs to do its work. We've written statements that generically talk about how to compute the diagonal of any sized rectangle, and we've returned that diagonal.